The trajectory of economic development can be broadly categorized into three main paradigms: growth, steady state, and degrowth. Growth refers to the continual increase in economic output, typically measured by factors like gross domestic product. This model assumes that resource availability and technological advances can drive ongoing expansion. The steady state model, on the other hand, proposes that economies should strive for a balance where resource consumption does not exceed ecological limits and social needs are adequately met. Degrowth challenges the notion that bigger is always better, advocating for a deliberate downscaling of production and consumption to enhance well-being and planetary health. An example of growth can be seen in the historical industrialization process, where nations invested heavily in factory-based production systems. These systems transformed natural resources into goods, bringing about significant economic expansion. However, as seen in many industrialized countries, such growth eventually leads to resource depletion, biodiversity loss, and environmental pollution. In contrast, initiatives like urban planning that prioritize green spaces or cities that cap the number of cars show elements of the steady-state model. A degrowth approach is embodied by communities that reject consumerism in favor of minimalistic lifestyles focused on shared resources, public services, and local economies. These models correlate closely with various topics in sustainability and IT. Growth has often fueled technological progress, though at a significant cost to the environment. The notion of a steady state aligns with concepts like sustainable computing, where technology is designed to minimize resource use. Degrowth provides fertile ground for exploring how information technology could enable shorter work weeks or sharing economies that reduce overall consumption. Each approach demands a reassessment of how economies interact with the ecosystems on which they depend. The alternative pathways of economic development can also be witnessed in the development of renewable energy technologies. While traditional energy sectors have focused on extracting more resources, the steady-state concept is embodied by solar panels and wind turbines that harness natural energy flows without depleting resources. On the degrowth end of the spectrum, initiatives such as community-led solar cooperatives not only shrink carbon footprints, but also emphasize human-scale, decentralized approaches to energy use, encouraging collaboration and local resilience over individual consumption. Each paradigm carries implications for the technological field. Growth often leads engineers to design more powerful and energy-demanding devices, pushing boundaries while consuming more resources. On the other hand, steady-state concepts align with the creation of energy-efficient hardware and software that prioritize performance without a trade-off against ecological health. Degrowth encourages the redesign of technology for repairability and longevity, resisting the planned obsolescence often present in many modern devices. These three economic models offer pathways to very different futures.